All right, students, let's start problem number 1 from the 5-1 notes. So what we're trying to do here is we're trying to find the rate of change using a table. So we're talking about a marching band, and it looks like as they march over time, their distance also increases. So it looks like they're moving forward. So what you need to do is, most of the time you want to take, so here's normally your x values and your y values. These would also be your inputs, these would be your outputs. What you want to do is you want to take the change in the outputs and divide by the change in the inputs. What do you mean by change? Well, how many did you add or subtract by? And that's what they do right here. So when you're going from 260 to 520, you can subtract, and that's, well, they added 260 feet. And they did that in, well, 2 minus 1, 1 minute, okay? Then they do the same thing again, okay? Same jump, they gained 260 feet in 1 minute. Same jump, you gain 260 feet in 1 minute. So this marching band is extremely constant and consistent in their marching, so they're well coached. So all you want to do is whatever jump you make over here, whatever change you find with your outputs, you want to divide it by the change in your inputs. So that's actually what got it questions. So this is what you do in your notes. So here's yours in your note packet. It says, in this problem, do you get the same rate of change if you use non-consecutive rows in the table? Let's go ahead and see. So let's jump all the way from 260 down to 1040. Sorry, my pen for some reason is not working very good. Okay, so we would jump here to there. Okay, so if you did 1040 minus 260, you would get 780. I'm going to divide that by 4 minutes minus 1 minute is 3. If you take 780 and divide by 3, guess what you would get? You would get 260 in 1 minute. Okay, so it's the same rate. So it doesn't matter if you do small jumps or if you do big jumps. As long as you do the change in your output divided by the change in your input, you should get a constant rate. Now, if it's a different number, then it's not a constant rate. But you need to make sure that you do the same jump on both sides. Either it's one at a time or all the way from the top all the way to the bottom, top to bottom. Again, how do you find change in general? You always take the new thing minus the old thing. All right, so change always equals the new piece of information minus the old piece of information. All right, that's problem number 1.